Hi everyone, it's Maggie, and in this video we're going to revisit atomic orbitals and look at three different graphs that describe the way the atomic orbital changes as we move away from the nucleus. Okay, and we're going to be doing that with this orbital, the 2s orbital. So the first function we're going to look at is the r function. Now this should be familiar to you. As a reminder, the r function describes how distance affects psi. Okay. And then next we have the r squared function, which you have seen before in relation to psi squared. And the r squared function tells us about the probability of electron position. Okay, and the last one we're going to look at is the d function. And the d function tells us about the probability of electron distance. Okay, so it might seem like the r squared and the d function are telling us the same information. So we're going to look at a couple example points to really tell the difference between the two of them. Okay, so we're going to look first on our r squared. Let's look at radius 1/2, so that'd be right here, and radius 4. So at 1/2, our r squared graph has a value up here, and at 4, our r squared has a value there. Okay, and so you can see by the difference in their values that we're more likely to be at the green point than to be at the blue point. Okay, and let's see what that looks like on our orbital. So our orbital, the green point would be pretty close to the nucleus, so right about there, and our blue point would be somewhere in the middle lobe. So yeah, the r squared tells us we're much more likely to be at the green point than at the blue point. Okay, let's contrast this to what the d function is telling us. So at 1/2, we have a value right here. And at radius 4, we have a value all the way up here. So now you can see it looks very different. In fact, we're more likely to be at a distance of 4 at r equals 4 than at r equals 1/2. Okay, so let's see why that is looking at our orbital. So the d function takes into account all the points that are at that same radius. And if you remember from our last video, when we're talking about all the points with the same radius, we're actually talking about the surface area of a shell. So when we're looking at the green point, we're actually looking at the surface area of this sphere here, all the points with the radius of 1/2. And when we're looking at the blue point on the d function, we're looking at all the points on the surface area of this shell. So even though we're more likely to be at the green point than at the blue point, because the surface area of that blue shell is so much bigger than the green one, we're more likely to be at that farther distance. So that's what the d function tells us. Okay, so it makes sense that the way the d function works mathematically is we're going to weight by the surface area. Okay, and so d equals 4 pi radius squared times big R squared. If you recall from our last video, the surface area of a sphere is 4 pi radius squared. So that makes sense. So if the difference between r squared and d function aren't quite clicking for you yet, there's another way you can think about it. It's really helpful to think about like you're playing a game of darts. So when you're playing a game of darts, the most likely place that you're going to hit is a bullseye because you're aiming at the middle. And that relates to our orbital because the bullseye of a 2s electron is the nucleus. And we can see from our R squared graph, the most likely position of our electron is at the nucleus. However, we all know when you're playing darts, you're more likely your darts end up here and here and here, all the way out here. So even though you're most likely to hit a bullseye, for the most part, your darts end up at a farther away distance. And we can see that in our D function. And so when we're actually talking about the electron's location, for the most part, we're going to be using the D function to describe it because that tells us a more realistic picture of where the electron is. So from our D function, we can see that our 2s electron clearly spends much more time in that outer lobe than it does in the inner lobe. And this is going to be really helpful to think about as we move forward.